a couple example problems from section 6.2. So here's problem 610, and we're given this curve, which is our voltage, and we're asked to find our current. Well, between 0 and 1 second, we go from 0 to 16. So our dV by dt is 16 over 1. So it went up 16 volts in 1 second. Or 16, I'm sorry, it's 1 microsecond. Forgot the micro. So it gives me 16 millivolts per second. My I is C dV dt. I know C is 2 milli, so I have 16 milli times 2 milli, or 32 kiloamps. My next one, between 1 and 3, is my next region. Now I wrote a 0. I meant to write a 1. Fix that. Between 1 and 3, I stay flat at 16, right? There's no change. So my dV by dt is 0. Therefore, my current is 0. And then our final region is between 3 and 4. And my dV by dt go down 16 in 1 microsecond. That's a meg. I thought something fell off there. It's megavolts. 1 over 10 to the minus 6 is going to give me a positive 10 to the 6, so mega. This will give me minus 16 megavolts per second. I equals C dV dt, 2 milli, times minus 16 meg, or minus 32 kiloamps. So if I plotted that, then I would have something like that, right? Where this is 32K, this is minus 32K, and 1, 2, 3, and 4. That's a terrible looking 4. Okay, let's look at the next example problem, 6.13. So if we look, this is a total DC circuit, right? Everything in here is DC. I have no AC components. If I have a DC circuit, I know that a capacitor acts as an open. So I can redraw this circuit with those capacitors as open circuits. That's all I'm doing is replacing the capacitors with opens. Now that they're open, I know that my current there is 0, but that doesn't mean my voltage there is 0, right? Voltage is the potential difference between two places. There's still a potential difference between those two nodes. And we want to find what that potential difference is. So there we go. Alrighty. What do we want to do? Well, we have options, right? We could do nodal, mesh, we can do a lot of different things, but let's just look at this for a minute. How do I want to do this? Let's draw a couple of currents in. Let's draw a current I1. And let's draw a current I2. What is I2 going to be? Well, I2 is flowing up to here, and there's a big hole. So I know I2 is 0, because you can't have current when there's a big, huge hole. I1 is going to be equal to the voltage from here to here is 60 divided by these 3 resistors. Now I can write these 3 in series because there's 0 current over here. So it's basically like this isn't here. No current drop, no voltage drop. I don't care about that resistor. So I have 30 plus 10 plus 20. I have a current of 1 amp. Now this voltage V1 is the voltage across here, right? Because these two are in parallel. So this node and this node are right here. So voltage V1 is the same as right here. So V1, V equals IR, is I1 times 30, or 30 volts. What about my V2? Well, I could do a KVL around here if I wanted to. I'd get minus 60 plus, I'll have, remember I2 is 0, so I1 is the only current flowing around here. So I have 20 times I1, don't care about that, plus V2 equals 0. I get a V2 of 40 volts. Another way to look at this V2, the voltage from here to here is V2. It's like this resistor's not here because of this open, so the voltage from here to here is V2. So my V2 has to be equal to the voltage across here plus this one. So it has to be equal to I1 times 20 minus, right, plus 60. So that's just another way to look at it if that makes more sense to you.